Hi everyone, today we're doing lesson 7.6a. This is again a review. We've already done this before the MCA, so we're just reviewing our exponential functions. As you may recall, our exponential geometric functions are written as y equals a times b to the x, where a is our starting point, our initial value when x equals 0, and b is our constant factor of change. It's always multiplication. So let's look at an example. I have, in this case, y equals 10 times 2 to the x. Well, if this were 0, anything to the 0 power is 1. 10 times 1, that will give me 10. What if I put a 1 here? 2 to the first power is 2 times 10 will give me 20. 2 to the second power, give me 4. 4 times 10 is 40. And here you can see that constant factor of change. Times 2 times 2, that's this number right here. So my next would be 80, and my one after that would be 160. Because 2 to the fourth power is 16, which times 10 would be 160. If I were to graph this then, I have 0, 10, that would be right here. 1, 20. 2, 40. 3, 80. And 4 would be off my graph, would be up here somewhere. You can see that growth curve that gets steep pretty quickly. Keeps getting bigger and bigger. So that would be exponential growth. It's growing quickly. Now here I have 1/2 is my factor of change. 1/2 to the 0 power is still 1 times 10 is 10. So my initial value is still this number right here. It's 10. 1/2 to the first power is half. Half of 10 is 5. 1/2 to the second power is 1/4. 1/4 of 10 is 2.5. And you can see your factor of change. You're multiplying by 1/2 each time. So 1/2 of 2.5 is 1.25. And half of 1.25 is 0.625. So if I were to graph this, I would have 0, 10, 1, 5. This is counting by 1, 2 ones. 2 would be 2.5, so 1, 2.5. 3 would be 1.25, so a little bit above there. And 4 would be 0.625, which would be a little bit more than halfway. And you can see this one is going down. It's going to be approaching that x-axis, but it's never going to touch it. Just keep getting closer and closer and closer. That will be exponential decay because it's getting smaller. Okay, now let's look at this example. We have 0.25 times 3 to the power of x. You might think this is exponential decay, but this is my factor of change. It is greater than 1. So my starting point is 0.25. Three to the first power is 3. 3 times 0.25 is 0.75. 3 to the second power is 9. 9 times 0.25 is going to be 2.25. Then again, you'll see I'm multiplying by 3 each time. So my next one would be 6.75, and then 6.75 times 3. I'm going to grab my calculator, make sure I don't make a math error on that. Is 20.25. So to graph this, my first one would be, well, this is 1, so it's going to be really close down here, because 1 would be halfway between 0 and 2. Then 0.75, that's not going to be quite halfway between, a little less than that, between 0 and 2. Then 2.25 is going to be a little bit above the 2. Then 6.75 is going to be almost to the halfway between 6 and 8. And then 20.25 is going to be a tiny bit above this line. And you can see that growth. And taking off. Oh, that is a bad line. So that is exponential growth again. Let's graph this one. This time I have 2/3 to the power of x. Now, what you should know is that number is less than 1. So this will be exponential decay. And each time we multiply, we're going to multiply by 2/3. But one thing you'll notice, it didn't give us our 0 value. So I'm going to put that right up here. We know this starts at 18. Well, 2/3 times 18. If this were 1, that would be 2/3 times 18 is 12. If I raise this, if I brought this to the second power, I would have 4/9. 2/3 to the second power. 2/3 times 2/3 is 4/9. 4/9 times 18. Simplify before you multiply. Oh, goodness. Hate when that happens, although it likes to often. Will give me 8. Eight times 2/3. 2/3 times 8 will give me 16/3, which is 5 1/3. I don't know why I did 18 times 4/9. I could have just done 12 times 2/3. It would give me the same thing. Okay, 16/3 times 2/3 will give me 32/9. 32/9. Is the same as 3 5/9. You'll see my numbers are getting smaller and smaller. And 32/9 times 2/3 will give me 64/18. Oh no, it went 64/27. Oh, I didn't multiply right there for a minute. Which is 2 10/27, which is a weird number. But you can see it's decreasing by 2/3 each time. So I'm starting at 0/18, then 1/12, 2/8, 3, 5 1/3. 4 will get me down here to 3 something. And then it should be a little higher than that. Then 5 will get me to 2 and something. Oh, 5's not even on there. And you'll see it decreasing pretty steeply. Oops. Until it starts getting near the bottom. And then it will keep going lower and lower, but will never quite hit this x-axis. Again, that is exponential decay. Okay, let's write a function for each one of these. Well, what's my starting point here? It's 2. And what's happening here? Well, it looks like it's multiplying by 7. So this would be 2 times 7 to the power of x. On this one, my starting point is 5. And it looks like I'm multiplying by 3 each time. So 5 times 3 to the power of x. On this one, you can see that I'm multiplying by 1/2. And my starting point is 64. So 64 times 1/2 x. And on this one, my starting point is 7. And I am doubling each time, so multiplying by 2. So 7 times 2 to the power of x. You'll see this is my only one that's exponential decay. The rest of them are growth. And let's talk about the penny problem. We've talked about this in the past. I put 0, 1, 2, 3, 4, 5. The reason I put those other numbers is it will help you when you think about moving backwards. I'm starting at 32 on day 6, 32 cents, so it's 0.32. Day 5 will be 0.16. Day 4 will be 0.08. Because this is a doubling problem, times 2 times 2. You can see that here, times 2 times 2 times 2. So I have 0.04, 0.02, 0.01, and then that 0 term will be 0.005. So as I double, you can see 0.005 doubled is 0.01, doubled 0.02, 0.04, 0.08, 0.16, 0.32, 0.64, 1.28. So my starting point is 0.005, and I am doubling, so 2 to the power of x. The ice bucket challenge, I believe we talked about this before too. Each one challenges 3 friends to do the same. It starts with 1 person, so it tells you it starts with 1. And each person challenges 3. So first day, you have 1. The next day, that person challenged 3. The next day, they all challenge 3, so that would be 9. And you'll see that it is multiplying by 3 each time. I already did my table kind of a little bit more less structured, I should say. Here we had a person started a secret. One person knew the secret. The next day, they tell 5 people. So the next day, we have 5 people. After that, each of those people tell 5 people. So each of those ones tell 5. So we're at 25 people they told. In day 3, they told 5 people. We have 125. This is growing very quickly. And then we have 625 people on day 4. That's the thing about telling secrets. So my starting point is 1 and increasing by 5, factor of 5 every day. So that's it. Remember, the a in our y equals a times b to the x. The a is our starting point when x is 0, and the b is our constant factor. Remember, factor means multiply, factor of change. That's it. Have a great day.